Hello everyone, we are going to solve this problem of differential equations and simple harmonic motion. So first of all, we have to understand what happens when a mass is tied to a spring. So let us say this is a spring, let's say some mass is tied to it, mass m. So when we release this mass at t is equals to 0, it goes down and then it comes up again. And it goes up or down and up in an infinite loop. But as t increases, when time increases, these oscillations become smaller and smaller in amplitude. When t tends to infinity, this mass attains a stationary position. Okay, so we call that position equilibrium position. So that means the mass stopped moving as t tends to infinity. So we call it a position where x is equals to 0. So let's say this is the position where the mass stopped moving. Then we call it stationary position or equilibrium position. All the distance will be measured from this position. To understand this, let's read the question. The position of a mass tied to a spring is given by this. So the position here is given by this function, and in which positive values of x represent the position below the equilibrium position. That means if x is equals to 2, which is positive, that means we are 2 units down the equilibrium position. So that means we are 1 or 2, so we are here. Okay, if x is equals to -1, that means we are 1 unit above the equilibrium position. Okay, so that means we are somewhere here, 1 unit above the equilibrium position. So, and what is the equilibrium position? Equilibrium position is the position of the mass when t tends to infinity. Okay, so now we have understood the process, so let's move forward. uh, Assume that mass begins moving at time t is equals to 0. When does the mass hit the lowest point? What is the lowest point? So the lowest point is the uh, point where mass reaches the maximum down. Okay, so first of all, let's find what is the initial position of this mass. Okay, so let's put t is equals to 0 in the function which gives us the position of the mass. Okay, so let's put t is equals to 0, then we will get x of 0 is equals to -1. So that means we are starting 1 unit above the equilibrium position. So if equilibrium position is somewhere here, then we are starting 1 unit above it. Okay, now we are going to drop this mass at t is equals to 0, then it will come down. So the graph of this, because the oscillations, the amplitude of the oscillation is getting smaller and smaller as t tends to infinity due to loss in energy. That's why the graph, if we plot the graph of x against time. So let's say this is time and this represents the value of x. Then at t is equals to 0, x is -1, so we'll start from here. But once we drop this mass, it will come down. Okay, so the value of x will increase because more it will come down, more the distance it will have from the equilibrium position, and distance from the equilibrium position downwards gives the value of x, which is tells, because the positive values of x represent the position below the equilibrium position. Okay, so if mass is here, let's say, then value of x is 1 or 2 unit. Okay, so it will increase, but after one point, when it starts to come back again up, then the value of x will decrease. Okay, so it will go on like that, but the amplitude every time will get smaller. Okay, so what is the maximum down it can go? So the maximum down it can go is at the first stationary point, at the first critical point. Okay, so we have to tell what is the maximum down it can go and at what time it will reach the maximum down. Okay, so we can clearly see that it will go the maximum down at the first critical point. So how do we find the critical point? So we can find the critical point by taking the derivative of x and then we will put it equal to 0. Then we will get the time at which the graph attains stationary points. But we are only interested in the first stationary point, because only at first stationary point we will get the maximum value of x. And the maximum value of x will tell us the maximum down this mass will go. Okay, so now the only thing remain is to find the derivative and put it equals to 0. Okay, so xt is equals to, we can write it as, we can take common e power minus t, and then it will be sin t minus cos t. Okay, now we'll take the derivative, x dash t is equals to e power minus t. So let's take the derivative of this and put the sin t minus cos t as it is, and then plus then put it as it is, and then take the derivative of term inside. Sin t, derivative of sin t is cos t, and derivative of cos t is minus sin t, so it is plus sin t. So this is the derivative. Okay, so this is the derivative. Now if I take e power minus t common again from the derivative, it will be e power minus t, so minus sin t plus cos t, then plus cos t and plus sin t. Okay, so from minus sin t plus sin t gets cancelled, so we'll get 2 cos t. Okay, e power minus t and 2 cos t. Now we have to put it equals to 0 to find the stationary points. Okay, so this term cannot be equals to 0, so that means 2 cos t has to be equals to 0, and since 2 cannot be equals to 0, that means cos t has to be 0. So cos t equals to 0 will give us the stationary points. And when cos is 0, so cos t is 0 when t is equals to 2n plus 1 by 2, sorry, 2n plus 1 pi by 2, odd multiple of pi by 2. ठीक है? Oh, okay, so cos t is 0 when t is the odd multiple of pi by 2. So since we are only interested in the first stationary point, okay, so we are only interested in the first stationary point, and we are also not interested in the negative integers or negative values of t. So what is the minimum value of n I can put here, so that the function, the t remains positive and minimum? So I can put n is equals to 0. If I put n is equals to minus 1, then t will be negative, so I'm not interested in the negative, but I'm interested in the first positive stationary point. So we will put n is equals to 0, we will get t is equals to pi by 2. So t is equals to pi by 2 is this point. Okay, so at t is equals to pi by 2, the mass will go the maximum down, or the x will have the maximum value, or you can say the mass will hit the lowest point at t is equals to pi by 2. Okay, so the answer to this question is, when does the mass hit the lowest point? It hits the lowest point at t is equals to pi by 2. If it asks us that what is that lowest point, what is that lowest point, so then we can say that we can simply put pi by 2 in this equation, and we will get x of pi by 2 is equals to that will be 0, it will be e power minus pi by 2. Okay, so this is the uh, this is the lowest point at which mass will hit, and it will hit at t is equals to pi by 2. So that's it for today, and thank you for watching.